Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's average level difficulty puzzle, and it's called Four Circles by Jolly Rogers. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9, once each, in every row, column, and box. Draw a one cell wide loop I think it's supposed to be of orthogonally connected cells, which does not branch or touch itself, not even diagonally. So, orthogonally just means that two cells share an edge. So these two are connected orthogonally, but these two would not be. They are connected diagonally. But for the loop, you can't even touch itself diagonally. So, as an example here, that's not good. Let's try this. Right. So this loop would be touching itself diagonally. So this is not a valid loop in this specific case. So we'd have to move and this would not be a valid loop because it's not connected orthogonally. So therefore we need to connect it here to form a valid loop. Adjacent digits along the loop must differ by at least 5. So this is the German whisper rule. So if this were the loop, this would have to be a 9 and a 9 because adjacent digits must differ by at least 5, and 4 can only be only 5 away from 9. So therefore, that's an example of the German whisper rule. Cells containing a big circle cannot be on the loop, and the digit in a big circle indicates how many of the up to 8 surrounding cells are on the loop. So, so circles containing cells containing a big circle, which are these 4 cells, which is 4 circles, cannot be on the loop. So they're not on the loop. And the digit in a big circle indicates how many of the up to 8 surrounding cells are on the loop. Well, so we know for this one, of the 8 surrounding cells, only 2 are on the loop that we're drawn. So this would be 2. Of these 8 surrounding cells, there's only 3 on the loop. And of these surrounding cells, which is only 5, there's 0 right now. So therefore this would be 0, but that's not possible. So therefore this loop does not actually work. But you can see from the example how to actually count the numbers or how to count so that you know what the digit is. And a digit in a big circle also indicates how many times that digit must appear in big circles. So therefore, if you were to have, say, a 1 there, you know that it only appears 1 time in all the big circles. Same with other numbers too. If you had a 7 in a circle, you would know that it would have to appear 7 times in the big circles. And obviously that leads to some certain things that you have realize. Anyways, that's that one. That's that rule. Digits joined by a small white dot must be consecutive. Not all possible dots are given. So this is called Kropke dots. And if this were, as an example, if this was a 6, this would have to be a 5 or a 7 to be consecutive with this cell. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So one thing that stands out is there are 4 circles. There must be at least 2 unique digits in the big circles because these 2 share the same column, and they have to be different, therefore. It cannot be 2 and 2. It can't be 1, 2, and 1 because obviously that double counts the 1. And the 1 would be in the circles twice. So it has to be 1 and 3 in the big circles. 1 appears once and 1 appears 3 times. Therefore, we know these 2 have to be the 1-3 pair because 1 only appears once in the big circles. Therefore, the rest of the big circles are 3. So this is 3 and this is 3. That's 3 in the corner. We celebrate because we now know, okay, so all the, let's just do, first, let's make them gray. We know this is 1 or 3, and we know this is 1 or 3. These two have to be 3. So that's 3 in the corner. We celebrate again because we know these 3 have to be on the loop. And we know at least 3, well, there has to be exactly 3. So this one can't be on the loop because it can't go here because it would touch itself. So it would touch itself any way it got in here because it would go here, then here. So this can't be on the loop. It cannot go here in this exit, so it would have to always go here. It can't go there, then exit, though. Therefore, these two are on the loop, and we don't know which one of these two are not. One of these is 1, and one of these is 3. It'd be 3 and then 1. But it can't be there. So let's try making this 3 and this 1. The problem is this has to go somewhere. So it has to go at least here. Or it could go here. But then how does it exit out without being more than 3? It can't, right? If it goes here and then tries to exit here, it's touching itself. If it tries to go like I can't even draw another one, right? So it either goes here or it goes here. If it goes here, it can't exit out because that's it touches itself there. If it goes here, it must get 3 here at least. So therefore, this is 3 and this is 1. So here means that it cannot go. I guess it could go that. Well, then the problem. Okay, so say it went this way. It doesn't work because it can't. It can only touch one of these, right? It can only touch 3 of these. So it touches 3 here. It has to continue on here, but then it can't go anywhere here. So this is out. So it can never go all the way here. So this one is out, and this one is out. Can it go like this? No, because the same thing. That's 3. So therefore, that's out. It can't go back on itself because it touches itself. Therefore, this is not possible. Therefore, it must go here, and it must go here. Now, if it goes this way, that's more than 3. That's touching this cell. So therefore, it can't go that way. It can't go back. So therefore, this is out. It has to continue here. It can't touch itself and then go back out. So therefore, this is all 3. Can't go this way anymore because we have all 3 that are touching here. So this is not valid too. This is not valid. It's possible it goes some. I don't even know. How would it go like this? I don't think it can, right? So say it went out here. It has to go back to touch the 1, but it only touches it once. So that's not valid. If it tried going here and touching, it touches itself here. So this one doesn't work, therefore it can't go that way, therefore it goes here, and then it must exit, so it can't touch any more of these. So these are all invalid, therefore we know that's part of it. This one, therefore, goes this way, which means none of these two are valid, because it touches itself there, therefore it must go here. These two must exit out this way. So it goes here, and it goes here. It cannot go this way because it would touch itself here. It cannot go this way because it touches itself here. And it can't touch itself at all, so therefore it can't be any of those 3. Therefore, this exits here, this exits here. Okay, so what happens if these are all low? If these are all low, because again, like on a German whisper line, you alternate between one set, which is low, and one set which is high, because 1 through 4 can only be next to cells that are from 6 through 9, or digits from 6 through 9, and vice versa. So it always alternates. Therefore, if these 3 were all low, one of them would have to be 4, because you have to have 1, 2, 3, and 4, but the 3 is already taken care of in box 7. So one of them would be 4, and they all see 2 unique digits. on the German whisper line. And that's not valid for 4. 4 can only be next to 9 on a German whisper line. And it has to be next to 9 twice, as I showed before in the example, to be next to 2 different numbers, to be next to 2 things on a loop. Therefore, this cannot be low, so all of these are high. Therefore, all of these are low, and they're next to 2 unique digits. So this must be 1 and 2. These have to be 7, 8, and 9 because they're all next to 2 unique digits. And 6 follows the same rule as 4, right? 6 can only be next to 1 on a German whisper line. And if it's next to 2 unique digits, it can't be a 6. Therefore, this can't be 4. These can't be 4. This must be a 4. This cannot be 4 from that. And it can't be 3 from here. So this is 1 or 2 because this is a low. This is a low. In addition, we know from, since the loop alternates between one set to another set and back and forth, vice versa, we know wherever you go to get back onto the loop, it's going to be maintain the same set, right? So this is a certain distance away from here. So it's 1, 2, 3, 4, 5 away. If you were to go, alternate, say just randomly on a loop, this would have to be red. Now the thing is, this would then always have to be red because it's always the same set that it's on, right? Because it alternates like a checkerboard. You have a checkerboard here. You always alternate between one color and the rest. If you excuse me, you always alternate on the loop, so you always would have to alternate again with like a checkerboard with a set. So no matter where you go or how hard or how far you go, it would always alternate back to the correct value. So therefore, since we know the correct set, so we know since this is alternates high, low, high, low, high, this always has to be a high number, which means this one always has to be low. This one is low. This one is low. These three have to be high. This one has to be low, and this one is low. So this is high. That tells us information about, so this one has to be 1 or 2. This one could be 1, 2, or 4. We don't know, because this could be 4 next to a 9 and a 9 possibly here. These all have to be 1, 2, and 4 because 3 is no longer possible. So this is 1, 2. It can't be 4 because of Sudoku. This cannot be 4 because it's next to 2 different digits on a German whisper line. And 4 can never be next to 2 unique digits. Therefore, this is a 4. A 4, not a 7. Which means it's next to 2 9s. This can't be 3, so this is 1 or 2. It cannot be 4 because it's next to 2 unique digits on a German whisper line. This can't be 4 because it either goes this way or it goes this way, which means it's next to 2 unique digits on a German whisper line. So this is 1 or 2. This is 7 or 8 because it's next to 2 unique digits on a German whisper line. And this is 7 or 8, so therefore this must be 5, 6, 7, or 8. If this is 5, 6, 7, or 8, it must be next to another 5, 6, 7, or 8. 4, 5, 6, 7, or 8, or 9, but 9's here and 4's here. So this has to be 5, 6, 7, or 8. This has to be 6, 7, 8. It cannot be 9. But if it goes on the German whisper line, say it tried to go here, it can't because there's no 2 numbers that satisfy that are 5 away from each other. So this one has to go here, which means this is a low, and we have a 1, 2, 1, 2 pair already there in row 6. So this cannot be 1 or 2. It can't be 4, so this must be 3, which forces this to be 8. Excuse me, I'm choking on something. I'm not sure what. So therefore, this can't be 8 here. And it's also not on the loop. So none of these can be on the loop because it can't get there and get out again. So these are not on the loop. If it tries going here, then here, it touches itself here. So these two can't be on the loop. So this one must somehow get to here. We don't know how. It could be here. It could be here. It could be here. It could be even here. But that's fine. So this one can never go up because it can't connect back here. So this is not on the loop, which means this can't be on the loop because it can't enter and then exit somewhere else. This cannot enter and exit this way anymore because then that would make this not be part of the loop or make it branch. Therefore, this is no longer allowed. Therefore, this cannot be on the loop. Let's see. Anything else? This must contain a 6 or 7, but we don't know which. Okay. 9 has to be one of those 3. Because of Sudoku. 3 is one of these 3. Okay, so this is 3. So this can't be 1, 2, 3, or 4. So this is 5, 6, 7, 8, and 9. If it were to continue any way into here, it doesn't work because this is never a low. So it always has to enter here, right? Because this one's no longer possible to be part of a loop because it would only be this way. It would have to be 9 and 9. It's not possible. So this always has to be a low, which means one of these is high, and then it could go to one of those two. So this is never part of the loop. So this is 1, 2, or 3. What other parts of the loop can we have? So it cannot continue this way, right? It can't be high then low, because if it's a low, that would be 4, and that would be next to necessarily 2 digits which are on a loop. So this one is out. So therefore this one's out too, because it can't go in and touch itself. So it goes to one of these two. That means neither of these two can be on the loop because it can't enter in and exit out without touching itself. So these two are not on the loop. It cannot go here in the touch itself, and it can't. This one always enters here or here, so therefore this can never be on the loop. So we have 3 cells now that are on the loop. 3 cells are on the loop. Yeah, all the loop parts, all the big circle parts are done. So now it's just loop. One of these is high, one of these is high. Can this be the last low? Possibly. There'd be 1, 2, 3. You have 8 and 9, 8 and 9. That's fine. Neither of these can be low. Well, okay. So this can't be 1, 2 because there's 1 or 2 here, and they would eliminate all possibilities here. This can't be 2, 3 because of that. This can't be 3, 4 because of that 3. This could be 4, 5, but then it would have to be 4 and 5 here. And this is 6, 7, 8, and 9, which is possible. So it could be 5, 6, 6, 7, 7, 8, 8, 9. This can never be low. Like a checkerboard pattern I talked about, it can never actually go here, because this would have to be a low for the checkerboard pattern on the loop. Therefore, this is not part of the loop. Therefore, we can never go here. You can never go here anymore. So this has to be on the loop, and this has to be high. This is low. It enters one of these two. It enters one of these two. It enters one of these two. And that's how it works. So this could actually be, it can't be 4. So this is 1, 2, or 3. We know the 3 is one of these two. Therefore, this has to be 8 or 9. It cannot be 7. It cannot be 6 because those can't be next to a 3. One of these two is high. If it were to, well, So the rest of this is 5, 6, 7, 8, 9. This can't be 8 because of that. This is 5, 6, 7, 8, 9. It can't be 9 because of these 9s. Therefore, this is 5, 6, 7, 8, 9. And that's valid. Again, it can't go through the white Kropke dot because those are consecutive. So it would have to either, if it goes here, it goes here. If it goes here, it goes here. We don't know anything about these two, right? So either this is high or it's low. This is 5, 6, 7, 8. Okay, this can't be 3. So this is 5, 6, 7, 8, 9. Ah, this has to be a low also. So this is 1, 2, or 3. Right? None of these can be low. Therefore, this has to be the only possible low. So this could be a high, which is fun. This could be a high. These are 4, 5, 6, 7, 8, 9. Obviously, these can't be 9. This can't be a 4 because of that 4. The 4 has to be one of those two. We know this is 5 and 6. Okay, so this cannot be 5 or 6, which means this can't be 4, this can't be 5. This can't be 8 and 9 because one of these has to be 8 and 9. Therefore, this has to be 7. One of those two has to be 7, and it's either 6, 7, or 7, 8. So this can't be 7. No 5 or 6 here. So this cannot be... It could be 1, 2, 2, 3. Cannot be 3, 4. Cannot be 5 or 6. It could be 7, 8, or 8, 9. It can't be 8, 9. So it's 1, 2, 3, or it's 7, 8. It can't be 7, 8 because this is 7, 8, and this is 7, 8, and 9. And that would eliminate all possibilities here. Therefore, this has to be 2. And 1 or 3. So this can't be 2. This is 2 with 1 or 3. This can't be 2 with 1 or 3. Therefore, it can't go from low to low. Therefore, it must go this way, which means it goes to high. Which means it must go this way, which is low. It could go either of this way. This is 7, 8, or 9. One of these is 2. We don't know which. This can't be 5 anymore. This can't be 6 because it's next to 2 unique numbers on the German whisper line. So there's a 7, 8, 9, 7, 8, 9, 7, 8, and 9 triplet in column 2. So none of the other cells can have a 7, 8, or 9. So it's a 5, 6 pair, 5, 6 here. This is not on the loop. Therefore, this is not on the loop, but we don't know which one of these two are. This cannot be a 6 and still be on the loop, so this is not on the loop. Therefore, this is on the loop. This can't be 5 or 6. Therefore, we have a 7, 8, and 9 triplet in box 4. So this can't be 8 or there cannot be 8 or 7, 8, or 9 in the rest of the box. Therefore, this is 5 or 6. This is 6, 7, or 7, 8. This could be 8. Could be 7. This cannot be 5 and 6 because that will eliminate all possibilities here. So therefore, this cannot be 5. Therefore, we know the 7 has to be here. It's 6, 7, or 7, 8. So this cannot be 7. This cannot be 7. One of these two is 7. One of these two is 7. Doesn't really tell us too much. To go here, it would have to go specifically this way. Which is possible. 3 has to be one of those two. We're not sure which. 3 could be here or here. So 3 is one of those 3. 4 has to be one of these 3. Cannot be any of these. So therefore 4 is here, which means this can't be 4, which means this is 4, which means this is a 9. Because that's the only possible one place for the 9 now. So this can't be 4. So this still could be here. And in fact, it probably is. This is 5, 6 with 7, 8. One of 7 or 8. So, okay, what do we have here? This is 3, 4, 5, 6, 7, 8. Obviously, this can't be 4. These can't be 3. This can't be 8. We don't have any other information right now. This is 5 and 6. So none of these could be 5 and 6. So we have 2, 3, 4, no 5 and 6. 7, 8, and 9. So this can't be 3 in any of these spots. This can't be 7. 1 is here. This can't be 9. Since this is, can't be 9. Since this cannot be 9, this can no longer be 4. So that's a 1, 2, 1, 2 pair in row 9. So this can never be 1 or 2 in the rest of the row. So this has to be 4, 5, 6, 7, 8, 9. Obviously no 8 and 9 here. This is 1 or 2. This is 1 or 2. So we have a 1, 2, 1, 2 pair in column 4. So none of the rest of the cells can be 1 or 2. So this is 3 through 9. This can't be 3 and 8, obviously. 3 has to be one of these two or one of these two. If it goes straight down, this would have to be 9, 3, and 8, 9. 9, 3, and 8, I guess, would have to be, if that's the case. That does seem possible, right? 9, 3, 8. And this, yeah, so this is possible still. Can you go this way? Probably. And so this would be 1 or 2. This would have to be 8 or 9. This could be 7, 8, or 9. Yeah, so both of those are still plausible. This can't be 7 anymore. This could be 2 as long as it's not on the loop. And then this would be 1. So the 2 is one of those 3. We're not sure which. Hmm. This can't be 4. So this is 5, 6, 7, 9 here. Hmm. Hmm. So if it went this way, this would have to be 1 or 2. Hmm. Yeah, we don't have any other additional information. 2's here. 1 has to be here. Which doesn't tell us anything. Hmm. If this is 7, this becomes 1, 2, 1, 2. This would have to be 3. Therefore, this would be 1 and 2. Therefore, this would be 3. Hmm. Hmm. So if it goes here, this has to be 9 and this has to be 8. And this would be 3, right? If it goes here, okay, so this is one possibility. It could go here. In this case, that's 8 or 9. This is 3, that's 8 or 9. So this would be 8. This would be 8 or 9 if it goes that way. If it goes this way, this would have to be 8 or 9 low, which would be 1 or 2, and then 7, 8, or 9. Hmm. Yeah, I'm not seeing too much. Hmm. So again, if it went here, this would be 9, this would be 3, this would be 8. If it went here, this would have to be 8 or 9, this would be 3, and this would be 8 or 9, which is possible. If it went here, this is 8 or 9 again. This would be 1 or 2. And this could be 7, 8, or 9. And if it goes here, this would be 3. Um, with 1 or 2. And 7, 8, or 9, 7, 8, or 9. This can't be 7, though, so. But the problem is that. Yeah. Hmm. One of these is 7, but that doesn't tell us anything. Because there are 1 and 2, 1 and 2. If this was 7. If this was 7, this is 8, this is 9. Right? And this would be 1, 2, 1, 2. This would be 3. Therefore, this would be 3. Therefore, this would be 8. Therefore, this would be 9. And this would be 7. And this would be 8. Ah, I think we have a contradiction. Let's say this was 7. If this was 7, this has to be 1, 2, 1, 2. Therefore, this would be 3, which means this can't be 3, which means this is 3, which means this is 8, this is 9, which makes that 7, which makes that 8, which makes that 7. So we have a contradiction. Therefore, we're just going to clear this back out. This cannot be 7, then. We know that for certain. This has to be 8 and 9, because we tried 7 there, and that led to a contradiction. Therefore, this is a 7. This cannot be a 7, so this can't be 7. This can't be 7, so therefore this is 8. Therefore this is 9. This is 8. This is 9, which leaves that as a 7. This is 8. So there cannot be an 8 here. There cannot be an 8 here. This can't be 9. This can't be 9. So, interesting. So if it goes this way, this has to be 9, 3, 8, right? If it goes this way, no matter what, this has to be 8. So 8's one of these two. So this cannot be 8, and this can't be 8. Oh, this can't be 8 because of this 8, so therefore this is 6. This can't be 6, so this is 5. This can't be 5, so this is 6. There can't be a 6 in any of these. This column. This can't be 5 anymore, therefore this is the 5. This can't be 8, so this is 6, 7, which forces this to be 8. Therefore, there's no 8 here. The 8 has to be one of these two. This could still be any combo. This could be any combo. This can't be 6 anymore. So 5, 7, 9, 5, 7, 9, 5, 7, 9. This can't be 6. It can't be 8. It can't be 9. It can't be 7. So this is 3, 4, 5. If it enters here, it's always... Well, we already knew it was always a low. This can't be 4 either. So this is the 3 or 5. Interesting. This can't be 7 anymore. These can't be 7. This is 1, 2, 4, and 8. Obviously, these can't be 8, so therefore this is 8. So these can't be 8. This can't be 8. Therefore, the 8 has to be one of these three, which means this can't be 8. So 8 has to be one of these two. This can't be 4 anymore, so this is 2 or 3. This can't be 8 anymore, so this is 7. So there's no 7s here. So this can't be 7, and this can't be 7, which forces this to be the 7, because it has to be next to 6 or 8. So 7 cannot be here, here. 7 is one of these two. This is a 5, 6, 8 triplet. So it can't be 8. This can't be 7 here. This can't be 5. So 6 has to be here. This can be 2, 3, 5, 6, or 8. Obviously no 3. It could be the 8. Could be the 2. Can this ever be 2? If this was 2, that means it would have to go this way, which means that's 3. So that's not possible. So this cannot be 2. Which means we have a 5, 6, 8 triplet in row 7. So the rest of them cannot be 5, 6, or 8. So the 3 must be here, the 2 must be here, which means this can't be 2. This can't be 2. The 2 is one of these two. So 8's one of those two. Therefore, this can't be 3. This can't be 3. This must be the 3. This can't be 3. So it still could go here and then here. That's fine. Um, hmm. This is 1, 2, and 4. So 4 has to be here because it's nowhere else in row 4. So this can't be 4. Hmm. This can't be 7. None of these can be 7. Therefore, this must be the 7. This can't be 7. This is 5, 9. So therefore, this forms a 4, 6 pair. 9's here. 9's here. This has to be 1, 2 with 5 or 9. So this can't be 9. This is 5 or 9. This is a 7 now. So it cannot go that way. It must go this way. So therefore, this must be an 8. So this can't be 8. It could... So this can't be 7. There's no 7s here. This can't be 3. So this is a 5. This is 8. This is 8. So this can't be 8. This is 7. This has to be 8. This can't be 5 or 7, so this is 6. This has to be 3, and that's a 4. So this can't be 4, so this is 4. This can't be 4 anymore. This can't be 5. Therefore, this is a 9, which makes that a 4. So it cannot go this way anymore, because this is low, and to enter here, it would have to be high. So therefore, this has to be low, and this has to be high. So these are no longer valid. Cannot be here because this is not a valid 5 can never be on a German whisper loop, so this is the loop. We can remove that. Therefore, this is 1 or 2. This cannot be 4, 5, or 6 because it's next to 2 unique numbers, so therefore it must be a 9. So this has to be 5, and this is 1 or 2, this is 1 or 2. This can't be 5. This is 5 or 6. This can't be 8, so this is 6, which makes that 5, which makes that 8. That's Sudoku. This is 6. This is 5. These can't be 9 anymore, so this is 9. 4, 7, 4, 7. So, this could be 2 with no 8. So this can't be 8. This can't be 7. This is 6. This is 8. This is 4. This is 6. This is 7. This is 4. This can't be 9, so this is 5. This is 9. We have 2 and 7 here. This can't be 6, so this is 7, which makes that 6, so therefore this can't be 2. So this, sorry, this can't be 7, so this is 2. This is 7. This can't be 2, so now this is the 2. This can't be 3, so this is 1. This can't be 1, so this is 2, which makes that 1, which makes this not 2. This makes that 1, which makes that 2. This is 6 and 5 from Sudoku. This is 2, which makes that 1, which makes that 2, which makes that 1, which makes that 2, which makes that 1, and that's 2. This can't be 1 or 2, so this is 3, which makes that 1, which makes that 3. And now we have, just finish it up, 5, and that's 1. And that's a solution. Yeah, fairly straightforward. Just take some, slow, methodical thinking to get through this part to basically know where the loop is. And yeah, pretty fun. Anyways, I hope you had a fun time too, and I'll see you next time on Frank Puzzles. Take care.